So welcome to Lesson 2B, Primary Trigonometric Ratios, Part 2. In Part 1, we really focused on how to write these primary trigonometric ratios. We also focused on how to solve the angles given the primary trigonometric ratios. What we're going to focus on today is how to solve for missing side lengths. Before we do that, I do have a minds-on activity here. I'm not going to waste time in the video going through it, but this should be great review from last class. So the first thing is to write out the acronym we use for the primary trig ratios, write them out for yourself, and here, using the information provided, create the correct trigonometric ratio, then solve for the angle indicated with the dot, round the angle to 1 decimal place. So pause the video now, try this as a review exercise. Once you play it, I'll have the answers on so that you can compare your answers before we move on to the new material. So this is the angles, these are the answers that you should have written down. The top was just SOHCAHTOA. For this one, you should realize that only the adjacent and the hypotenuse was given, so we use cos. So cosr is adjacent over hypotenuse. Something I want to emphasize here, if you can simplify the ratio, you should. Don't keep it in, don't have a fraction that's not fully reduced. And then we solved for the angle using the inverse trig ratios. Same thing here, we noticed that we were given the opposite and the hypotenuse, so we used sine, and then eventually solved for g. So this is what we did yesterday. What we're going to do today in today's lesson is finding the side lengths of a triangle. So the trigonometric ratios can be used to determine the side lengths of a triangle as well. In order to do this, you must know at least one angle and one side length of the triangle. Okay, so as you can imagine, or if you can compare, in these questions, to solve for an angle, we needed two side lengths. We needed two side lengths to create a ratio, then we can solve for the angle. If we're trying to solve for a side length, we need at least one angle and one side length. So steps, solving side lengths. Label the side length that you want to solve with a variable. Write the correct trig ratio that includes the side length that you want to solve, and isolate for the variable through cross multiplication. So let's see what this all means. Exercise, solve for the indicated side length, round side lengths to 1 decimal place. Solve BC. Remember, a line over BC just means solve for the side length of the line segment connecting B and C. So we need to first, as it mentions, label the side that you want to solve for with a variable. We've learned how to name side lengths. We know that a side and its opposite angle should share the same letter. So this is A, so this should be A, but it's the lowercase version of A. Okay, so that's the first thing we have. The second thing we have here is that we are given an angle of interest. Based on our angle of interest, we know it's a 90-degree angle, so this is a right triangle. We can label our opposite, adjacent, and hypotenuse. So the hypotenuse would be here, the side opposite of the 90-degree angle. Here's our angle of interest, so this side is our adjacent, and this side is our opposite. Okay, so in this particular question, we were given, let me circle them, our hypotenuse, and we want to find our A, so that should also be included within our ratio. So in a situation where we're given opposite as well as hypotenuse, we have SOHCAHTOA, we're given opposite and hypotenuse, that represents sine. So we have sine, the angle of interest was 20, sine 20 is equal to opposite over hypotenuse. The opposite was A, and the hypotenuse was 5. So this is the ratio we were able to create. Now we need to isolate for the desired variable through cross multiplication. If you use cross multiplication, it will always work. In order to use cross multiplication, you need fractions on both sides. Here we have a fraction, A over 5. This we're going to convert to a fraction by doing sine 20 over 1. Once we have this, we can cross multiply. So cross multiply just means multiply diagonally. So the first diagonal we have is 1 times a. So where 1 times a is just a, you write that on one side. The other multiplication we have 5 times sine 20. So we're going to write that on this side. Something to note, if you have sine in an angle and you're multiplying it with the number always comes up front. So we have 5 times sine 20. So we write it like this. Okay? Once you get to this point, you've isolated for your variable here. It's a. To solve for this, you're just plugging it out into your calculator. So I'm just going to write it out. 5 sine bracket 20 is equal to 1.710100717. And based on the instructions I was given, I should round the side lengths to 1 decimal place. So it's around 1.7. Again, let's quick review of what we just did. So what we did was we labeled the side length we wanted to solve for using the rules we've already learned. This is capital A, the opposite side length should be lowercase a. Then we created the trig ratio with the side length that we want to solve for. So we were given the hypotenuse here. We wanted to solve for the opposite, so we made a sine ratio, which is opposite over a hypotenuse. So sine 20 is equal to a, the opposite, divided by 5. To solve this, we use cross multiplication. Convert this to a fraction, multiply across, so 1 times a, is equal to 5 times sine 20, which is 5 sine 20. It's not wrong for you to write it like this or to put 5 times sine 20, but now that you're in grade 11, you should become more comfortable by just writing 5 sine 20. And then it was just calculator work where I figured out it was approximately 1.7. So what that means is that a here is about 1.7, and that is its side length. What I should mention is none of these diagrams are proportional. They're not to scale, which is why this is 5 and this is 1.7. We're essentially using them as a guideline to create our trig ratios. Let's try the second question then. Here we're already again given our angle of interest. So our angle of interest is right here. It's 45. Okay, so something you should notice here. Okay, and this was a mistake on my part or something to do with the computer, sorry. But if I had given you this diagram and you had used SOHCAHTOA, you would be wrong. Why? Because there's no indication here that there is a 90-degree angle, that this is a right triangle. Now, it was my fault. I missed it, but that's a good lesson. Don't assume angles that aren't present there. We are going to put the sign in to show that this is a 90-degree angle, however. Okay? So in this question, we want to solve for the side length of line segment DF. So DF, this is the line that connects them. I'm going to label it. Again, its opposite vertex is capital E, so it shall be named lowercase e, based on the rules we've already talked about. After this, we can label the 3 special sides. So here is my 90-degree. The opposite would be the hypotenuse. Here's my angle of interest. The side associated with that is my adjacent. And here is my opposite side. So based on this, I was given my adjacent. I know I need to include that in my trig ratio. I also want to solve for E, so I'm going to also include that in my trig ratio. So my trig ratio will have adjacent and hypotenuse. So if I go look at SOHCAHTOA, it's Ka that has the adjacent and hypotenuse. So I'm going to go with cosine. So the cosine of my angle of interest, which was 45, is equal to adjacent, 7, over hypotenuse, which is E. Okay? So I've written out my trig ratio. The point is to solve for E there. Again, we're going to use the same method we used before. We're going to use cross multiplication. So I'm going to convert this to a fraction over 1, and I'm going to multiply across. Okay? When I multiply across, here again, 1 times 7 is 7. And here, e times cos 45, again, treat e as a number because it represents, no, treat as, it's a variable, but it represents a number. So when we write it, we're going to write e cos 45. So again, the variable or the number comes before cos 45. Now, the difference between here and here is we still haven't isolated for the e. Remember what the e means here. It means e times cos 45. So if I want to isolate for the e, I need to divide both sides by cos 45. So if I divide this side and this side by cos 45, these cancel out, and I'm left with e is equal to 7 over cos 45. Okay? Right now, you've isolated for e. There's nothing you can do except for plug it into your calculator. So be careful here. We are dealing with fractions, so I suggest that you put things in fractions. Again, it would be all of this in brackets divided by all of this in brackets. So 7 divided by cos 45. Notice how I put the numerator in a bracket and the denominator in a bracket. And that's about 9.994, whatever. So 9.899494937. Again, I want one decimal place, so that's 9.9. So the side length here of e is actually about 9.9 units. So something I wanted to emphasize here, which a lot of people make mistakes on, is you can never separate the angle from the trig function unless you use the inverse function. But you always want to keep them together, which is why we wrote e separately times cos 45. It's okay to have these numbers in front. It doesn't make sense to put them after. So that's the first thing. The next thing is, even though we have something like e cos 45, the way you should read it is e times cos 45. So to isolate for the e, I do the opposite. I divide by cos 45 on both sides, which is how I isolated for the e here. It's no different than when we had something like 7 is equal to 14e, and to isolate for e, I divide both sides by 14. The difference is what you're dividing by is cos 45 in this case. Okay, so give me 2 seconds as we switch to the next page. Okay, so we have one last question here where we are solving for a specific side length. So in this case, again, we've been given our angle of interest. It's right here, 70. And we want to find the side length YZ. So YZ, if I take a look, is right here. So again, this is opposite to x, so its name is lowercase x. Once I have that, I can name the different sides of the triangle. So here's my 90-degree angle. The side opposite of that is my hypotenuse. Here's my angle of interest. The side close to that is my adjacent. And the side opposite is my opposite side. In this case, I've been given adjacent. I want to solve for x. So those are the two side lengths I will use to build my trig ratio. So again, taking a look at SOHCAHTOA, here I have opposite and adjacent, which is tangent. So the tangent at 70 degrees, which is our angle of interest, is equal to opposite, which is x, over adjacent, which is 4. Again, to solve for this, I'm going to create two fractions so I can cross multiply them. So this is the same thing as saying tan 70 over 1, and I multiply across. So on this side, I have 1. It's lagging a bit. Sorry, 1 times x, which is just x. On this side, I have 4 times tan 70. Again, the 4 comes up front. So 4 tan 70, which again just means 4 times tan 70. I've isolated for my x. That was the goal of this question. All I have to do is plug this into my calculator. So when I plug it in, 4 tan 70 is equal to 10.9899098. Again, if I'm rounding it to one decimal place, that's about 11.0. Okay, so hopefully this is clear. You would have practice solving questions like these last year, but just keep in mind. So there's really only two types of questions we've seen so far then, where we create the trig ratio and solve for the angle. In that case, we need to go for the inverse trig ratios. That's what we did last video. And then this video, where we create the ratio and solve for a particular side length using cross multiplication. So those are all the tools that you need. And all of these tools were building up to this particular type of question called solving right-angled triangles. If you are asked to solve a triangle, you need to find all the side lengths and all the angles of the triangle. So if on an instruction in a near evaluation, I say something like solve this triangle, that means find all of its side lengths and find all of its angles. That's your goal. To do this, you have three tools at your disposal. The primary trig ratios, so cosine, sine, tangent, which we've been talking about. We have Pythagorean Theorem, which you talked about in grade 9 and 10. So remember, that's a squared plus b squared is equal to c squared, where c represents the hypotenuse. And we have the sum of the angles of a triangle. We know that the three angles of a triangle will add up to give us 180 degrees. So we can use these tools, the trig ratios, Pythagorean theorem, as well as the sum of the triangles, to solve the following triangle. So here we have this question. It says solve the following triangle. Now, before we begin, I want you to label your triangle. I am going to make a slight change here because it just makes the question much less confusing later on. I'm just going to change the B and the C here. So this is going to be called our C, and this is going to be called our B. Okay? Everything else stays the same. So I want to label everything first. Ignore the whiteout. I tried something. It was a bit confusing, so I'm just going to redo it, which is why I switched the C and the B here. Okay? So we have our vertices named. Now I'm going to label my side lengths. So here we have A, which is opposite to here. So this is also A, but lowercase a. This side is opposite to this, so this would be lowercase b. And this side is opposite to this, so this would be lowercase c. What I like to do with these questions is I like to list out all 6 things that I eventually want to solve for. So remember, if it just says solve the following triangle, you want to solve for all 3 angles as well as all 3 sides. So I'm going to label them down here. Angle A, angle B, angle C. I know at the end I should have values for all 3 angles, but also A, B, and C. By the end, I should have values for all 3 side lengths. What I do now is I plug in the information that I already have. Here, I know lowercase a is 2. I know lowercase c is 7. I don't know lowercase b. I don't know angle A or angle B, but I know angle C is 90 degrees. So I've been given 3 of the 6 pieces of information that I need. What I want to or need to do is now solve for the other 3 pieces of information. So let's start with the side lengths. I have 2 side lengths. I want to find the third one. This is the perfect scenario to use the Pythagorean theorem. So remember, with the Pythagorean theorem, we have a squared plus b squared is equal to c squared, where c represents the hypotenuse always, and a and b represent the other side lengths. So here a is 2, so 2 squared plus b, which is what I want to solve for. So b squared is equal to c squared, where c is 7. I can simplify this. 2 squared is 4 plus b squared, which is equal to 49. To isolate for b squared, I'm going to bring the 4 to the other side. So here it's a plus, the other side will be minus. So 49 minus 4. So b squared is equal to 49 minus 4, which is 45. And so b is equal to the square root of 45. Remember, the square root of 45, we can break it down because that's the same thing as saying square root 9 times square root 5, which is just 3, the square root of 9, root 5. So now we've solved for b, which is 3 root 5. I'm going to add that to my list here. So now we've solved for all three sides. All we need to do is now solve for the angles. I wasn't given an angle of interest in this question, so I decided to just make b my angle of interest. If that's my angle of interest, again, this is the side that's opposite of the 90-degree angle. This is my hypotenuse. This is the side close to my angle of interest. That's my adjacent. And this other side is my opposite. So I want to figure out the angle. I'm given all three sides, so I can make either a sine ratio or tan ratio or a cosine ratio. But what I suggest is to use the side lengths that were given to you in the question. So you were given adjacent. You were also given hypotenuse, so use that to form your ratio. Why? Because let's say you calculated this incorrectly. You don't want to use that value and make all the other answers incorrect as well. You want to use the values that were given because those are more reliable. So in this case, you were given adjacent and hypotenuse. If I write out SOHCAHTOA, adjacent and hypotenuse is cosine. So the cosine of your angle of interest, which we don't know, so angle B, is equal to adjacent over hypotenuse, where adjacent is 2 and hypotenuse is 7. So I have cos B is equal to 2 over 7. I want to isolate for the angle here. Remember, when we're isolating for the angles, we use the inverse trig ratio. So I'm going to take out my calculator. Here I have cosine, so I want the inverse of cosine. I'm going to do shift and cosine. That gets me the inverse trig ratio. The inverse function, sorry, and then I'm going to put the ratio to 7 in brackets. And so B, again, is about 73.3984, so on and so forth. I'm not going to write out the entire thing. It says round all angles to a whole number and all lengths to one decimal place. So if I want to round this to a whole number, that's just 73 degrees. Okay, so angle B is about 73 degrees, and we can write that in here as well. That's another piece of information that we have gotten. The last thing we need to do is solve for angle C. So we have angle B now. We know it's about 73 degrees. We have angle C. Sorry, we have to solve for angle A. We have angle C, which is 90 degrees. We want to solve for angle A, and this is where we can use this third property that we know. We know that the sum of the three angles in a triangle, so the angle A plus angle B plus angle C should give me 180 degrees. I don't know what angle A is, but I know angle B is 73 degrees. I also know angle C is 90 degrees. So now I can isolate for angle A. So angle A, 73 plus 90 is 163 degrees, which is equal to 180 degrees. And now to isolate for angle A, I move 163 to the other side. There it becomes minus. So 180 degrees minus 163 degrees. Angle A is 17 degrees. And now I can plug that in. Again, I'm going to put a dot there because that's still approximate. That is about 17 degrees because we assumed that B was around 73 degrees. Now we've solved for all the angles. We've solved for all the side lengths. We essentially have solved this triangle. So whenever, again, they ask you to solve a triangle, you're just trying to find all the side lengths and all the angles using any tools that you have at your disposal. For right angle triangles, that's SOHCAHTOA, Pythagorean Theorem, as well as the sum of the angles of triangles. Let's try another question here. It says solve the angle where D is 6.1, angle E is 90 degrees, and angle F is 22 degrees. Here, I didn't give you a triangle, but using these clues, you should be able to draw one. The thing that you should immediately see is that one of the angles is 90 degrees, so you know you have a right angle triangle. So let's write that in. Okay. You also know that angle E, 90 degrees happens at angle, is called angle E. So the vertex here is E. You also know that you have another angle called F, and F is 22 degrees. So let's put that in, 22 degrees. They also give you side length D, which means one of your other vertices should also be capital D, and you should label the sides. So if this is capital D, this is lowercase d. If this is capital E, this is lowercase e. And if this is capital F, this is lowercase f. So again, they wanted me to know that lowercase d, or the side length d, is 6.1. But to find where that side length is, I had to put the other vertex in, capital D, and then look for its opposite side length. So I'm going to label everything they've given me. D is 6.1. I've labeled F, and E, again, this sign tells me that it's 90 degrees. So before we start the question, just like last time, I want you to label everything that you need to find. So angle DEF, as well as side lengths DEF. And again, just like last time, I want you to label everything that you've been given. I don't have angle D. Angle E is 90 degrees, and angle F is 22 degrees. Here, the side length D is 6.1. I don't have side length E or side length F, but that's what I want to solve for. Okay, so the thing that jumps out at me already is I have two angles. To get the third angle, I can use what I did over here. I know these three angles should add up to give me 180. So angle D plus angle E plus angle F should give me 180 degrees. Angle D here, I don't know, plus angle E is 90 degrees, plus angle F, 22 degrees, which is 180 degrees. So angle D is 90 plus 22 is 112 degrees, which equals 180 degrees. Then to isolate for D, I move the 112 to the other side, so 180 degrees minus 112 degrees, so angle D is 68 degrees. So the angle was quite easy to find. Again, label that here. So we found all three angles. Now all we need to do is find the particular side lengths. So the tools we had were sum of angles. We reuse that. In order to use Pythagorean Theorem, you need to know at least two of the side lengths. We only have one side length here. So we're going to have to figure out another side length using primary trig ratios. So there's multiple ways of doing this, but I'm going to choose one of these to be my angle of interest. I'm going to choose F here to be my angle of interest. Okay. I'm also going to choose a side length to solve for. In this case, it's going to be F. I'm going to try solving for F in this case. You could have gone with E, that's totally fine. I'm just going to go with F. So I want to solve for F. I'm given this particular side length as well. So let me label these sides. Here's my angle of interest. I know that this is my hypotenuse. This is my adjacent, and this is my opposite. So I want to form a ratio with my angle of interest. I've been given the adjacent, I have that number, and I want to solve for my opposite. So opposite and adjacent essentially gives me tan. So I'm going to use that here. So the tangent, of the angle of interest, 22 degrees, is equal to opposite over adjacent, opposite being F here, so that's what it mentions here. F is my opposite, and adjacent is 6.1. These are the types of questions we saw today, where we're trying to solve for a side length. So we make two fractions, and then we do the cross multiplication. So on this side, we have 1 times F, which is F. And this side, we have 6.1 times tan 22, which is 6.1 tan 22. Remember, the number comes up front. I've isolated for f. All I need to do now is plug this into my calculator. So I have 6.1 tan 22, and that gives me 2.46455. And the instructions above said all lengths to one decimal place, so that's about 2.5 units. Okay, so I've solved for f, which I'm going to record here. Now, the only thing I have left to do is solve for e. I have two side lengths now. To solve for the third side length, I can use Pythagorean Theorem. So Pythagorean Theorem is usually written as a squared plus b squared is equal to c squared, but here we're using different letters. So we're going to write it using these letters. Using these letters, remember the c squared is always the hypotenuse squared. So I'm going to have that on one side, and on the other side, I have the other two letters. So d squared, one of the side lengths, plus f squared, the other side lengths, equals the hypotenuse squared. So with this formula, the hypotenuse should always be on its own and squared to one side. So let's plug in what we have. D we know is about 6.1 squared, plus f, which was about 2.5 squared, is equal to e squared. These are nice numbers. I will let you use a calculator for this. So 6.1 squared, I'm just typing it into my calculator, is 37.21, plus 2.5 squared, which is 6.25, is equal to e squared. I'm going to add those two things up, so that gives me 43.46 is equal to e squared. And to isolate for e, I'm going to take the square root of 43.46. So e is equal to the square root of 43.46, which is 6.5, about 6.59. Again, I want to round it to only one decimal place, so it's about 6.6. So I've solved now, again, all three angles and all three sides. What you'll notice is that, yes, we used all three tools in each case. We used the angle rule, we used Pythagorean, we also used the trig ratio, but the order in which we use them can differ depending on the types of information that have been given to you in the question. Okay, and that's what we see here. I'm going to do one more quick example and then we'll be done for today.